Okay, four more examples for section 8.1. Again, now this basically the directions are telling you using u substitution the a squared minus u squared. And again, the integral rule for arc tangent goes like this, or excuse me, arc sine is an a squared minus a u squared, and that's equal to arc sine u over a plus c. So, in this case, u is going to be equal to the square root of x to the sixth, which is going to be an x cubed, which means du is going to be equal to 3x squared dx. And hopefully you can see that matches the numerator. And a is going to be equal to the square root of 16, which is 4. So du, I should have done this earlier, du over 3 equals x squared dx. Alright, so now when I integrate this, I have a 1/3 out in front. I have a 1 over the square root of a squared minus u squared, right? A squared minus u squared, and then a du. And that matches arc sine. So now I'm going to do 1/3 arc sine of u over a, and then plus c. All right, you just got to recognize that it's a trig integral. All right, next one. This one's just difficult. Again, you're going to try a couple things. You're going to try u substitution. It's not going to work. So here's basically what you do for this. And there's a couple ways to do this. I'm just going to show you the one way that that I did this one. You can add and subtract e to the x just to the numerator. So basically you're adding 0, which isn't changing the actual problem. And then when you do this part, you can break it apart, meaning I'm going to break it right there. I'm going to integrate 1 plus e to the x over 1 plus e to the x, which is going to be 1, which would be a pretty simple integral, dx, minus, and then an e to the x over 1 plus e to the x dx. So now, I'll come up here with this. I'm going to integrate, that's going to be a 1 dx minus integrate e to the x over 1 plus e to the x dx. And this is going to be u substitution, so let me take care of that. Oh, god darn it. Alright, hopefully I didn't screw up things too much. Okay, so integrate 1 dx is just x, and then for the second part we're going to use u substitution. So u is going to be equal to 1 plus e to the x du. The derivative of 1 is 0. The derivative of e to the x is e to the x dx, and that matches the numerator. So now I can rewrite this as the integral of 1 over u du. So that's going to be x minus the integral of 1 over u is the ln absolute value of u, which is 1 plus e to the x, and then plus c. All right. Again, that's a difficult one to realize that you need to add and subtract. I believe it also works if you multiply the numerator and denominator by e to the x. You'll get something slightly different as what the answer looks like, but it'll be an equivalent answer. All right, next. Yeah, these directions, the disguised form of a power rule, that should be for the next question. These directions should be using trig identities, using trig identities. All right, and the identity is that 1 plus tangent squared x equals secant squared x. So tangent squared x is equal to secant squared x minus 1. And again, if you tried u substitution, it's not going to work. All right, so we're going to replace tangent squared 2x with secant squared 2x minus 1. So rewrite this as secant squared 2x minus 1, and that whole thing dx. And again, you break it apart, and that's a secant squared 2x dx minus 1 dx. And you're going to have to go back and check out your integral rules for secant squared x. That's when you integrate that, you get a tangent. So got to do a little u substitution first. So u is equal to 2x dx. And then du is equal to 2 dx. So du over 2 equals dx. So now when I integrate this, I'm going to have a 1/2 integrate secant squared u du minus, I'm just going to rewrite this one, integral of 1 dx again. And now I can actually apply rules. So it's 1/2. The integral of secant squared u is tangent u, which was 2x. Whoops, 2x. And then minus the integral of 1 is just an x, and then plus c. And again, please understand this is not an integral for an arc sine and inverse trig one. All right, and then the last example, these directions should say a disguised form of the power rule, disguised form of the power rule. And what you need to, and again, try use substitution. In this case, it's going to work, but when you do use substitution, you're going to let u equal the ln of sine of x. And what you're going to see happens here, that when I do the derivative of that, the derivative of ln of u is u prime, so derivative of sine is cosine u prime over u. Well, cosine over sine is equivalent to cotangent x, right, dx. So I can rewrite this integral of the cotangent x dx is going to be du, and then the ln of sine x is equal to u. So it ends up being a pretty simple integral if you recognize what to do. And now it's just going to be a u squared over 2 plus c. Substitute back in for u, so it's going to be the ln of sine x, that whole quantity squared, over 2 or times 1/2, and then plus c. Okay, and if you look at the last page, these are all the possible techniques that you can use, and you can look through them. I think we didn't do example number 1 where you can just kind of multiply that out, FOIL that out, but I think we did all the other ones. Yeah, this is number 4 is the long division one, and then you get your trig ones, trig identities. So, okay, hopefully it helps.